Good morning everyone. I hope everybody is doing fine. So last day we had completed the trigonometric part. Now we have to start off with left hand and the right hand limit concept. So left hand limit basically means numbers line left, the thing we have done in the introduction class. The left hand, supposing I say limit x tends to 0, so left hand limit means things, all the values of the function which is less than 0, and limit right hand limit means all the functions value greater than 0. So out here you can see you have to find limit x tends to 0 and x tends to 1. Okay, these are two different questions merged into one, where f of x has given to you two functions, one for x less than 0 it's 2x plus 3, and for x greater than 0 it's 3x plus 1. So right, for first we'll be doing is x greater than x tending to 0. So for x tending to 0, first you have to find left hand limit and right hand limit. If these both are equal, then the limit will exist and the value will be found later on. And supposing the left hand limit of x tending to 0 will be 2x plus 5. We'll be picking up that function because less than 0 you have 2x plus 3. Okay, so when you pick up this value and you put x tending to 0 out here, then you get 2 into 0 plus 3, which is 3. Okay, now x tending to 0 plus means right hand limit. Right hand limit greater than 0 is 3x plus 1. So in 3x plus 1 you put 0, you'll get 3. So left hand and right hand limits are same, you get 3. So the limiting value is also at x is equal to 0, it's 3. Therefore, if left hand limit and right hand limits are equal, then you say limit exists and the limit's value is, you put the value. Okay, now the second part is x tending to 1, for 1 less than and 1 greater than. Acha, all greater than 0 you'll be picking up that value only, because less than 1 you'll be picking up that 3x plus 1. For both greater than and less than 1 you'll be picking up 3x plus 1. So 3x plus 1 comes out to be 6, and that also 6 right hand limit. Now I hope you understood that why we have picked up 3x plus 1 and not that one, because tending to 1, one's left and one's right means less than 1 and greater than 1. Both are same because x greater than 0, function value is 3x plus 1. So I hope you understood this numerical, kindly copy it down. After having done this numerical, we'll be moving on to question number 24, which tells us that to find x tending to 1. This is a fairly simple one, and less than 1, one function, less greater than 1, one more function has been given to you. So for less than 1 you have, for left hand limit you have the upper function, for right hand limit you have the second function. So calculating the values just by merely putting out the values, we get 0 on first, and right hand limit we get -2. So since you can see left hand and right hand limit are not the same, so you can clearly write that the function the limit does not exist and the left hand and the right hand limits are not equal. Okay, similar it's for 25. You have two functions, one not equals to 0. Not equals to 0 means greater than less than 0, you have mod x by x. Okay, and for equal to 0 you have 0. So for left hand limit we'll be picking up the same function, and right hand limit also same thing. So for left hand limit, you know, mod x is always less than 1. Okay, so you get a value of -1 left hand limit, and right hand limit will get +1, you see, because mod x is always greater than 1, greater than 0 for all the positive values for x. So you get limit is 1. So it is observed that left hand limit is not equal to right hand limit, so limit does not exist. And now question number 26 is the same numerical. Denominator is, it's just having mod x, it's same, exact same limit will not exist, because mod functions mostly the limit doesn't exist. Okay, unless it's mod x by mod x. Okay, so that's it. Now question number 27, x tending to 5, where limit's value is mod x by mod x minus 5. So left hand limit first you have to find out, to find the limit. So left hand limit out here, you will be taking x will be negative, so you put out here x is negative, so you put 5 first, -5 and -5. So x less than 5 you have put out, and mod x, so you'll be just merely putting 5, because when x is equal to 0, mod x is equal to x, and when x is again greater than 0, mod x is equals to x. Now out here the limit value is x tending to 5 and not 0, that is why you're just checking. So you're taking values less than 5, so less than 5 it's out positive only, so you'll be just putting the values. You'll get minus 5, 5 minus 5 is 0. Now for x is greater than 0 out here, obviously whenever you put x greater than 0, mod x will always be positive, that's it. So you just put minus 5 out there, 5 out there, 5 minus 5 is 0. So left hand limit, right hand limits are same, so you can conclude at the end that the limit x tends to 5 is f of x is 0. Okay, now 28 will be done later on. Today class we have done enough 5 numericals, so I hope you understood all of these things, and you have to let me know if you have any problems and submit the assignments as well. Okay, and study well for your exams. So thank you, bye bye, have a nice day.